Welcome back to the Explainer. Okay, let's just state the obvious. For the first time in over 50 years, humans have finally left Earth's backyard. We're going to unpack the Artemis II mission, a 10-day journey that was so much more than a test flight. It basically reopened the highway to the moon and everything that lies beyond.
To really get the historical weight of this mission, you have to hear this message from Apollo astronaut Jim Lovell. It's incredible. It's this powerful, symbolic passing of the torch from one generation of lunar explorers to the next. Absolutely amazing. So, here's how we're going to break this all down. We'll start with the historical context. Then we'll dive into the hardware and put Orion through its paces. After that, we'll look at the human side of things. And finally, see how this all sets the stage for Mars.
Okay, first things first. It is so important to understand that this was not just another space flight. For over half a century, we've been tethered to low Earth orbit. This mission, this was us finally cutting that cord and heading back out into the deep cosmic ocean. Just look at that gap. 54 years. Think about that. Since 1972, every astronaut has stayed inside the protective bubble of Earth's magnetic field. Artemis II was the mission that sent people back out into that harsh, unforgiving radiation environment of deep space for the first time in a generation. So you can think of this whole mission as the ultimate dress rehearsal. You don't just decide to land on the moon or build a base there. First, you have to prove beyond any doubt that your brand new rocket and your brand new capsule can safely get a crew all the way there, around the far side and all the way home again.
All right, so let's get into the good stuff. The tech. This mission was all about taking this incredible new hardware and pushing it to its absolute limits. So how did it do?
The leap from Apollo to Orion is just staggering. It's not an upgrade, it's a whole different beast. It holds more people for longer, and the computing power is, 20,000 times faster? But honestly, the real game changer is the power. Instead of finite fuel cells, you've got these massive solar arrays. That's the key. That's what makes long-term missions possible.
Really, the whole mission was just a giant checklist designed to stress test everything with actual people inside. Can the life support handle a full crew? Can the engines fire perfectly to leave Earth's orbit? Can the crew actually fly this thing by hand if they have to? And the big one, can that heat shield survive re-entry from the moon at almost 25,000 miles per hour? That's way, way faster than coming back from the space station. So you might think a perfect, flawless mission is what they wanted, right? Well, actually, no. On a test flight, you want to find the kinks in the armor. And yeah, Artemis II definitely ran into a few real-world problems, which is exactly what it was supposed to do.
Believe it or not, even the glitches were a huge success because they provided priceless data. Yeah, there was that famous issue with a new space toilet. Turns out it wasn't ice causing the problem, but probably some chemical debris. Finding that out now on a test flight, instead of on the mission that's actually trying to land on the moon, that's a massive win. Okay, so the hardware is one thing, but this mission was just as much about the human element. Let's talk about the 4 astronauts inside that capsule and the new ground they broke, both literally and scientifically. And what a crew it was. They named their spacecraft Integrity, and it really represented a new era of global cooperation. You had NASA's Reid Wiseman, Victor Glover, and Christina Koch, alongside Jeremy Hansen from the Canadian Space Agency, the first non-American to ever fly a lunar mission. Just a fantastic team. Then, on day 6 of the mission, they did it. They flew farther away from our planet than any human being in history. They officially broke the record set way back in 1970 by the crew of Apollo 13. It's more than just a number. It's about pushing that boundary of human exploration just a little bit further out. And this is why we send people. They brought back a perspective no robot ever could. They saw Earth set with their own eyes. They spotted meteoroids hitting the lunar surface. And they said the moon wasn't just gray, it had these surprising shades of brown and even green. That kind of human observation is pure gold for planning where to land next. Now check this out, because this is some straight-up sci-fi stuff. The astronauts weren't just pilots. They were walking, talking science experiments. They flew this experiment, called Avatar, which had living bone marrow cells, taken from the crew themselves, growing on a chip. This lets scientists see exactly how deep space radiation was affecting their tissue in real time, without any risk to the astronauts. Incredible. And all this science is absolutely vital. Why?
Because we have surprisingly little data on how the human body holds up in deep space. So the crew was covered in sensors, tracking radiation, sleep, stress, you name it. They were gathering the very first modern data set we have for how to keep people safe on those long voyages to the moon and eventually to Mars.
So this brings us to the big question. What was it all for? This 10-day flight wasn't just about going back to the moon. It was about laying the critical foundation for humanity's next giant leap.
At the end of the day, Artemis II was the final exam for NASA's new deep space ride. It proved that the massive SLS rocket and the Orion capsule work just like they're supposed to, with people on board. They passed with flying colors, which means NASA can now, with confidence, move on to the next, even more ambitious phase.
And here's that roadmap. Artemis II was step 1, prove the hardware. Check. Next up, Artemis 3 and 4, actually land people on the moon again. From there, you start to build a base camp, a place where we can have a sustained presence. And all of that, every single step, is about learning what we need to know to achieve the ultimate goal, sending the first humans to Mars. This quote really just says it all. This is the entire vision of the Artemis program in a nutshell. The moon isn't the final destination anymore. It's a training ground. It's a proving ground for the much longer, much harder journey to the red planet.
So the success of Artemis II leaves us in a totally new place. The question isn't if we can go back to deep space anymore. We've answered that. The real question is, now that the path is open, what are we going to do? We've proven we can visit again. Now comes the hard part, figuring out how to stay.